So they can hear me on Zoom, I think.
Loud and clear.
Okay, great. Hi everyone. We don't have a ton of people in the room here. There are a number of people online as well. So we're going to keep it kind of informal and casual. We'll talk about containers today and DHIS2 in containers and in more high availability environments. But yeah, think about your use cases and what you would like to discuss, because we're a pretty small group, so we can talk about it a little bit more informally. We do have a couple presentations today. We have Felipe joining us from Chile online. I'm not sure what time it is there, Felipe. What time is it over there?
7 in the morning.
7 in the morning. Thank you for getting up early for us. Good morning. So we'll be, I'll just give a quick intro. Probably everybody who's joining this session is already fairly familiar with what we mean by containers when we say containers. But I just threw together a few slides giving a quick intro for those that aren't familiar. There's a lot more that could have been added to these, so this is very high level, and probably there's some details that are missing and things like that. But what we talk about when we mean containers, it's a lightweight way to virtualize basically a process in a Linux machine. It's lighter weight than a full virtual machine. LXC is what is the basis for a lot of the systems that we are familiar with, such as Docker and others, and that is basically a kernel level way to isolate different systems within a Linux machine. So we got a few more people joining here, which is great. Docker comes up quite a bit because that's kind of the hip, it's been around for a little while now, but the hip way to do containers. There's a number of other ways that you can basically tools for building, running, and managing containers. Docker is one of those. LXD, which is by Canonical organization, is another one. And Podman, which is Red Hat, I believe, the organization, is another one. Those are all more or less equivalent. They have some differences, but basically they're tools for building and deploying those LXC containers. Who is Docker by? Docker is by Docker. Docker is the organization. Yeah. It's not anymore. Ah, interesting. Yeah, so there's a number of details in here as well. There's been an evolution for a lot of these tools as well over time. Yeah, so basically containers, I guess I put LXC there, but containers, the main difference I would say between Docker and LXD, and maybe Bob can back me up on this as well, or add some nuance, is that Docker is focused on virtualizing an application, whereas LXD is more about lightweight virtual machines. That's I've read that description online a few times. I'm not sure. You can use them both to some extent, but that's kind of the ethos, I guess, that the two are kind of approaching. Would you agree with that more or less? Yeah, kind of exactly. And Podman is kind of the more recent one of those three. It's been basically it's billed as an alternative to Docker, so it's basically a drop-in replacement, more or less, and has obviously some differences and a different organization that's running it. And then we have more container orchestration on the right side here. So I just listed a couple again. There's many others. Docker Compose is fairly simple, but it is a way to, in a single file, you describe kind of a setup or a topology of multiple containers that then get kind of deployed and connected automatically in this case, Docker. And so this is what we talk about when we say orchestration is you have more than one container that work together to kind of provide the full service of an application or a use to solve a use case. When you can then take that to kind of the next level and have much more sophisticated ways to do that orchestration. Docker Compose only works on a single machine, but if you want to spread it out over multiple machines for redundancy and scalability and all these different things, you have to start doing a bit more sophisticated work around scheduling when containers start up and stop and how you distribute those containers over all of the different nodes that are then talking to each other and the latency between the nodes and scaling up and down services based on the demand and the load that's coming in. Fault tolerance. So if errors start happening, how can you roll things back? How can you do upgrades in a seamless way? There's lots of things that can container orchestration can provide for you, and there are tools that can do that. Some of those are Kubernetes. Another one is HashiCorp Nomad. HashiCorp has a few open source tools for this. That's a little bit different than Kubernetes, but has a similar kind of approach in terms of managing services that are spread across different nodes. In this case, it doesn't actually have to be containers, but there's a few other things as well. And there are many other examples of these, but Kubernetes is by far the most well-known. So I just wanted to give kind of a very high-level intro to these concepts for those of you that aren't familiar. I just wrote this slide up in a few minutes, so probably there's a lot more that I could expand on or go into if we wanted to deep dive. And there are others who are much more expert at this than I am, who could probably correct half the things that I have on this slide already. Yeah, but just to start off, does anybody have any initial questions or things to add or things that you think are missing kind of from this very high level? What are containers and what are we talking about when we're talking about containers? Online, feel free to speak up as well. Yeah. 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 So the question was for those online. The question was what on the right side here, if you were to set up a horizontally scaled deployment of DHIS2, those are the tools that you would use. And the answer is, though, you can use those tools for that for sure. So one thing that Docker is again kind of focused on an application level kind of encapsulation. If you have basically one process running in one Docker container, and that process is DHIS2 running in Tomcat, for example. If you want to have two Tomcats, you need two different Docker containers. And once you have more than one Docker container, then you need the things on the right something to be able to kind of orchestrate those together and figure out how your DHIS2 deployment now becomes 2 or 3 or 10 things working together, and they have to know how to talk to each other. You have to map network and disk and all these different things. Usually all of these have a concept of kind of a private network for those services to talk to each other, and then certain ports and certain network adapters to talk to the outside world. So then you have usually some sort of an ingress management where the requests that are coming in are then routed to the services internally, and the response are routed it back. So all of that happens on the right here. On the left is a lower level where you're actually just kind of encapsulating the individual process or service. Docker Compose is only on a single node, yes. They used to have Docker Swarm, and it still exists, but it's been kind of deprecated. And that was around kind of basically a swarm of nodes that then you could roll out like that. I don't believe you can do Docker Compose across nodes. I don't know if anybody has experience with that, but I don't think that is currently supported. Yeah, basically. I think I'm sure that Docker has some plans to move into that space again or to expand on it. There's some, I don't know, there's a whole bunch of history as well with, I think Docker Swarm got kind of like sold to another company. I don't know. There's a whole thing. Yes. So these ones, the top here, Docker Compose is only a single node. Kubernetes and Nomad, and there are others as well. What's another? Mesos, I think, is another one. Apache Mesos. There are several ways that you can basically spread things out over multiple services. Okay, any other questions or comments? And I'm sure when, at least when Felipe gives his presentation, we'll learn a bit more about the right side of this, potentially. Okay, this one I actually will turn it over to Bob at one point to take a look at, but I wanted to talk about a few of the things that we, as the UIO team and DHIS2, do related to containers. There's more than this, but this is kind of a starting point. And one of those is the server tools that Bob and Tito and the server support team have put together to basically to automate and standardize the way that you can deploy a secure and performant and well-designed set of services to run DHIS2, and that uses LXD and containers under the hood. So it's basically just containers for running DHIS2 and the different services that are associated with it, with some isolation between those services and from the outside environment. And I'm sure that Bob could expand quite a bit on that. And there's more, lots of details, and you can see all of the Ansible playbooks that run these different containers at that GitHub link. Bob, do you want to add anything to that just to start off? No? Okay. Another one, we do produce official Docker images with all of our releases. So all of our builds of DHIS2 version 40 that just came out last month. There's an image on Docker Hub. So you can go to hub.docker.com and then you find the DHIS2 repository or DHIS2 organization and the core repository. And you can see builds, official builds of our releases of DHIS2. We also build development builds and canary builds that you can find on there as well. Every PR is also built and published there, but these are the official releases that are packaged up as Docker containers. We don't yet recommend those for production. We've been trying to kind of be a little bit conservative in that because there are things that we want to make sure are in place before we strongly recommend those for any production implementation. That being said, there are people that have already tried to do this and are maybe using Docker in production. So we're working on things like security hardening. I know this is something that Bob and Michael, who's in the back, and Phil and I have had a few conversations about, and we'd like to do more of this because we're producing these Docker images, but they're kind of frozen in time. And as security issues might occur in some of the underlying images that the containers are based on, we want to make sure that we have a mechanism for updating the even older versions of DHIS2, updating them based on security issues that might arise, and otherwise also just kind of optimizing those images for production use, whether that's performance optimization, security optimization, lots of things like that. And this is kind of part of an overall move or kind of push towards becoming a little bit more native in the container world. So this includes things like configuration that lives on the file system is not exactly the kind of paradigm that a lot of containers, containerized applications use. And so there are ways we could improve the way that DHIS2 behaves to work better in containerized environments. And there's kind of a push for doing more of that over time. I don't know, Bill, Bob, Michael, if you want to talk at all about DHIS2 Docker images, maybe you have a couple slides later on. I'm not sure. Yeah. Instance manager. Yeah. I think that's the next one. Okay. Yeah. So if you have any questions about those as well, feel free to ask us about the Docker images. Probably you'll be seeing more kind of attention to and support for different types of deployment in the future. And then last one here is D2 cluster. I threw this in here, not something that anybody should be using in production at all, but it is just basically a wrapper around Docker Compose. So you can also find a standard Docker Compose for DHIS2. And this is just a command line tool for spinning up and down and seeding databases in a development environment. So it might be something some people are interested in. We'll hear about another tool in the presentation from ICT today as well that I think is quite interesting in kind of this space of Docker and DHIS2 and some development environments as well. Yeah, Phil, do you want to talk a little bit about infrastructure management?
Okay, can you hear me? You can hear me. Okay, yeah, this slide is just to give a bit of insight into how this affects us as well as implementations and you guys too. So, you know, in our internal infrastructure, we have to host a lot of instances. So I think, you know, we use them for demos. You're all probably familiar with the Play server. We also, you might be familiar with Demos server. But in addition to that, we have many other servers or virtual machines that we use with many instances on, which we use for testing, we use for training. So the sort of online academies, the instances behind there. We use for development, different aspects of development, including package development, for example, so actual metadata development. All these things have sort of instances that we host behind them, which have various requirements, some very close to kind of production, like others, different sort of requirements. But we also, because we've got multiple teams using these, we want to make it easy to manage those. And we've been using Ansible and various other systems, and as I said, running these on virtual machines. But we've taken a step over the last couple of years to try and shift that and to take more advantage of containers in order to support the sort of requirements that we have for our teams internally. And these are the things like we want to set up a kind of self-service system where people can run up instances when they need to run them up temporarily for many of these activities. When it's self-service, it needs to be quite intuitive in terms of like an interface, just start something up, stop it as you need, and so on. You also want it to be fast, responsive to get things running and then get rid of them. I put there, it's built to support our workflows, and the point is that, as I say, they're sometimes quite different than a production workflow, but there are a lot of overlaps as well. Some things are very relevant to production support. And we want things to be low maintenance, of course. We want things to take care of themselves. We want things to auto scale if we need more resources. We want things to auto restart if there are issues that bring things down. We want things to clean up. If people forget about instances that they don't need anymore, we want them to be removed from our resource pool and so on. So there are various things like this. And we do want them to be secure. We don't want to sort of compromise our own infrastructure. So it was just to introduce that we have all of these kind of same problems internally. We've been building the system. There's a kind of image of how we're aiming for it to look. We've got actually an interface which implements some of this, and we've got quite a fairly complete backend based on Kubernetes that manages our instances. So we're starting to shift over to using those more and more in our environment. So yeah, I think I can demo some of this at some point if necessary, but I think
maybe after. Yeah. Great, thanks, Phil. Yeah, and yeah, as Phil said, this is something that we're starting to use a bit more internally. It also helps us to work on the development of, like I said, more container native and more scalable DHIS2 in general. And a lot of these tools could be of interest to the community as well. So there's something we want to look into how we can share and how we can build them in a way that's not specific to just our use cases, but probably we know that there are a lot of other organizations and implementations that build or run multiple instances of DHIS2. Even within a specific country, you probably want a development and a staging and a test instance and a production instance, and you want to manage them, and you want to manage upgrades, and you want to manage databases and all of these different things. So having a kind of a streamlined way to manage those could be quite helpful. So something we want to explore. I think this is my last slide here. Yeah, so these are going to be for after. But I think to start off, I'll open it up for maybe 5 minutes of questions, and then ask Felipe if he can present on the work that they've been doing in Chile around scalable and containerized DHIS2. Any questions or comments to start us off with what we've said so far? You? Sure. Yeah. Just waiting on the microphone.
So I have a question. When using Docker containers, how about the customization of DHIS? If you want to do a customization at the code level, is it possible? I don't think it is possible. Is it possible to use Docker?
So you mean if you customize the DHIS2 war file or instance?
Yes.
So in that case, you would not use the official instances that we publish, but you can use the same. Basically, there's a Docker image is an output from the build of DHIS2. So even if you modify the code and you run your Maven build commands, there are a few additional commands you need to run, but you can get a Docker image out of that, right? So that's another way to generate a Docker image, and you can even customize some of the templates and things like that. It's using Jib, yes, to generate those Docker images. So it's part of that build process. It's out of the box.
You will have to create our own image.
Yeah. So you don't actually. Well, yeah. So basically, there's a Maven command that generates a war file, and there's also another Maven command that just generates a Docker image, and your output is a Docker image that you can use. That being said, another kind of direction that we're moving to some extent is trying to make things more modular, so you don't need to fork and rebuild a lot of the pieces of the core. So that's something we've been working on for quite some time with modularity in applications. I'll talk more about kind of how we can try to support some more kind of service-based architectures for different things within DHIS2. So hopefully in the long run, moving away from needing to fork and then merge upstream changes and things like that. But that's a little bit of a bigger discussion.
Thank you.
Yeah, I think you had a question as well. And my colleagues in the audience, feel free to jump in if you have any comments on any of these. Yeah.
That's good. Is this good?
Yeah.
So I guess I'm just trying to figure out, like, if I wanted to run DHIS2 on my Mac laptop, is this a good way to do it? Is it going to be a lot slower? I assume it's easier to set up. Like, maybe this is off topic, but what are the pros and cons of that? You can just tell me it's off topic, and I can ask you about it later too.
So I think, I mean, it's not entirely off topic, but I mean, it's a little bit different than a production use case, right? So one thing I would say, an advantage of doing that versus running it natively, is that you have all of the dependencies bundled into a container, right? So instead of needing to have a local Tomcat and a local Postgres, and if you want to test it on multiple versions of Tomcat, then you need to have multiple versions installed locally or run VMs or something, you can put all of that into a single container. So there is that is one of the advantages of containerization, and it's very helpful in the development process as well, to be able to kind of encapsulate the entire development tool chain into a single place. So there definitely is an advantage, and this D2 cluster was designed and is used by a lot of our team as well as other people to be able to spin up DHIS2 instances for testing pretty easily. And that's, the only thing you need for that is Docker and NPM. And then or Node, and then you can run basically an instance very quickly. But it's also just a Docker Compose under the hood, so you could just use Docker Compose to do that same thing. So it's definitely useful in that sense, I think. And that's one of the challenges that you run into a lot when you're trying to kind of mutate the configuration or the state of any server or system. It becomes more complicated, whereas Docker and Docker Compose are declarative. So you know what is there, and you can modify it and then redeploy a new copy and take down the old one, instead of trying to always mutate the state and keep track of all the different dependencies that you have going on in your system. So yeah, go ahead. It shouldn't be that much slower. There's a little bit of overhead for containerization, but especially for development or workloads like that, I wouldn't say that there's any performance implication.
No, I agree. You shouldn't find significant performance. I just wanted to comment on the previous question. People rolling their own implementation, because there's a bit of a tension there, because there's kind of advantages and there's disadvantages of rolling your own versus using somebody else's published images.
Yes. Yeah.
With some of the advantages of rolling your own is, like, you can package your own WAR file.
Yeah.
But the other thing is some of the security concerns. If you've got a sudden vulnerability in your SSL library or whatever it might be, if you've got the power to roll your own, you can deal with it at the implementation stage. The downside being, part of the benefit of using the official image is that all these combinations of Java version and Tomcat and what have you have been tested. So when you roll your own, you lose that benefit and you move into supporting yourself much more again.
Yeah, I just wanted to completely agree with what Bob just said. When I said trying to move away from not rolling your own Docker images, but forking the core and maintaining separate code bases. So absolutely, I think there is an advantage to rolling, or there can be an advantage to rolling your own Docker image, and it's a fairly light kind of wrapper around DHIS2. You have a WAR file that's then exploded probably in the image itself, and then you have a few of your dependencies, and you can roll that yourself if you'd like. So yeah, good point. We had one more question, and then we'll move to Felipe.
Yeah, thank you for that. So my question goes to, I have a situation whereby you have multiple instances. You want to run multiple images. Yeah, so you want to run multiple different countries, and you want to have this zipped up in Docker or a Docker image. So which approach is best for that? You're running the normal DHIS2 with all the metadata and everything around it, and you have the organization unit and all the structures formed around that. But then you want a much quicker way of doing the deployments that is in production. And so you have maybe 2 or 3 different countries that are running separately, but you want them to be able to just quickly spin up their own instances of DHIS2, their own separate servers. So would it be better to use the Docker images? Currently, I've been using the D2 cluster, but of course that's still on development. It's not yet on production. So which will be best? Yeah.
So there's a couple couple different angles to try to answer that question. One is, I mean, you mentioned metadata configuration and org units and things like that. Typically, this is talking about the processing power, right? The software itself and not the data. So the data would live in a database, which is the database might be running in Docker or it might be running in a container, but probably yeah, I would say always your actual database data would live on a disk somewhere still, right? So you'd still need a logical database somewhere, or a physical data disk somewhere holding that database, and that can be using a Docker volume. There are a few ways to kind of map or mount different disk space to containers that would run that. So I don't think that these tools, there's a little bit of a, there are some tools that are working on in the instance manager that Phil demonstrated to manage databases as well, and backups of databases, and basically starting a new instance from an existing backup, and lots of things like that that could be relevant. But Docker itself and containers itself wouldn't solve that problem for you. You can, yeah, there are ways you might be able to basically bundle your database as a Docker image or something like that, but I wouldn't recommend it. That being said, a lot of these tools, and it's not one of them, right, that is better than the others necessarily, but a lot of these tools could help with the problem that you're mentioning of needing to be able to quickly spin up new instances for a new country or a new person. So the instance manager is a good example of that, in that at that point, it's just you click a button and you have a new DHIS2 instance with a Postgres database and an Nginx gateway all set up in a configuration that you've defined. Maybe you start the database from something that already exists, or maybe you start a new one. And you can do some of that even with just Docker Compose, for example, or D2 cluster, which is, I wouldn't recommend again for production. Docker Compose is what D2 cluster uses under the hood, and then you can define, I want a DHIS2 instance, I want a Postgres instance, I want an Nginx gateway, I want the disk for this Postgres instance to be mapped to this physical disk that I have. You can, yeah, set up the forwarding of ports and all of that for your instance, and then that sits in one file, which you can then basically run as many copies of that, the images or the containers that are defined in that file. You can spin up new ones as you'd like, and it'll spin up the whole set of things that you need and expose them in a certain way. So that's one way to do it. That's the lightest weight way, but something like Kubernetes or a more sophisticated orchestration platform have a lot of concepts of they call deployments or different things like this, where you have this set of services. You maybe have different scaling requirements for different services within that. So maybe you want to have 3 copies of DHIS2 running, talking to your database, or maybe you have all sorts of different ways that you can set that up. So you can use all of them in some way. And I don't know if there's one specifically that I would say is the best for it, because it depends on your requirements. I don't know if anybody has another answer or suggestion in that regard. Yeah. Yeah. And the other one is at the top here, right? You could also just create a new virtual machine and use the Ansible tools to set up a new version of or instance of DHIS2. That's another way that's a very repeatable, standardized way to set up DHIS2 instances. Okay. So think about your questions or things that you would like to discuss as we get a little bit further in this. I think there are a couple. Okay, yeah, there are a couple comments in the chat. Renee, thank you for answering those. But maybe Felipe, will turn it over to you. So I'll stop my screen share and you can tell us a little bit about what you've been doing and what is going on in Chile.
Yeah, sure. Actually, I'm gonna try to answer a few questions that I heard.
Oh, sure.
They were really good. Let me share my screen. Are you seeing my screen?
No,
No.
not seeing your screen right now.
Okay.
This one?
Now?
We see the slides, but is this your screen or is this just the slides here?
But yeah, the slides.
Yeah, can you try to switch the slides to the next slide? Yep, we see it.
Yeah, okay. Yeah, that's good. Well, hello everyone. I'm connecting from Chile. I'm part of the Ministry of Health, and we are actually pretty new working with DHIS2. We started in October last year, and well, I think we have done a lot until now. And today I'm going to present you a bit about the infrastructure that we're working on and why we did work with Kubernetes. Well, a little bit about Chile, because I know that most people don't know about it. Actually, it's the longest country in the world, and that is a big challenge because, well, you have different ecosystems and also different health facilities around the entire country. If you take it on top of Norway, as you see in the map, it would take like from the northern part of Norway to almost Egypt. And actually, that's for you to dimension how long is the country. We have the desert on the north, we have glaciers at the south, and well, it's pretty difficult to work here because you have many different ecosystems and things like that. But the important thing here is that we are working with DHIS2 to solve these issues. Why we started working with this? Well, because, well, we need a DHIS system for collecting data from the entire world, country. And actually, it was pretty simple to work. But we started, as everyone I would say, well, at the beginning, working in our own computer, using Docker Compose, as Austin said, and then we started looking for something that would have higher availability. And that's how we moved to a Kubernetes-based infrastructure. Actually, even though you see this, I'm going to tell you a bit more how it works later on, then don't worry if you don't understand. But what I want to tell you, and it's more important, is that you can deploy DHIS2 in local-based servers, as most people do. But I would recommend you to move to the cloud if you have the possibility. Why? Because I think that it's more secure, and actually you have higher availability if you're going to deploy something that is countrywide and is going to be used for many people. I've heard a lot that most countries are moving from aggregate data to tracking individual data. And actually, that is also important for performance. Then you're going to need a high or a better infrastructure. Then why Kubernetes? Well, actually, you can see here everything that you need to configure or you can configure using Kubernetes. And the important thing here is that, well, the meaning of Kubernetes is a word that comes from Esperanto, this like international language that, or universal language, I would say, and it means captain. Because it's the captain that is going to control or orchestrate, how they say, everything that happens at infrastructure level and also at app level. And that helps you to deploy an application really fast and infrastructure really fast and control everything. Then everything goes into a container level, as you all mentioned, and you have a pod running that is going to have that container, and then you can control the infrastructure using Kubernetes. The good thing here is that you're going to have high availability by default because it could work with one pod or many more. To the next one. Oh, okay, there. And everything is secure inside of a virtual private cloud in this case. Then even though you have this that is exposed to the world, actually everything that is inside or within the network, the private network, is going to be controlled by you. You can say what IP can connect to any machine, or how you are going to control the Kubernetes engine. Actually, you can add some cybersecurity layers for having not only layer 2 and 3 of cybersecurity, or firewalls level 2 and 3, but you can reach layer 7, what is pretty cool actually. It's a good standard for working with when you're going to have nominal data from patients. Then how we work, actually, you need to have your Google Kubernetes engine. Well, in this case, we're deploying in Google. I didn't say that. For working in Google, you need to have a Google Kubernetes engine, and you're going to deploy your database in another pod or another service that in this case is called Cloud SQL. If you're going to work with more than one workload or one pod, actually, you need to have a Redis database that is going to share the cache between the machines. And actually, you can do some pretty fun stuff. For instance, what we do in general, we work with the DHIS2 Word file, as Austin said. We download that file, and then we do a Docker build with our necessities, I would say. We push it into the artifact registry, where you're going to have all your containers. In this case, you could have similar services in other places. And actually, we do some DevOps where it deploys automatically if you want it, and it's going to update all the pods or all the machines without taking down the service for the person that is using the service or is registering in DHIS2. That's the most useful thing, I would say. In this case, you have nodes. If you don't know much how it works, and those nodes, that it could be a machine, I would say, a server in general, you are going to have pods inside a node. You can have multiple pods. You can have one, and it would work like a normal virtual machine, but you can have multiple pods deployed in just one node, or you can have multiple pods in multiple nodes. Then this makes simple to escalate horizontally, as you mentioned there. And you can have some levels for making this expand or contract as you need, or as the application needs. Then it's going to optimize also your costs in general. How does it work? Then you have some limits and some requests. That is your base level that you're going to be using. And you have another levels of, well, like for requesting. For instance, when you work with normal servers, you work with one CPU, you're going to need 2 CPU or 3, 4, 5. In this case, you can use a millicore that is mentioned, and then you can optimize the service for using 300 millicores or something like that. That is 300 milliparts of a CPU. Then you can even use lower levels of a CPU, and that makes it even cheaper for the service that you are running. You are going to have some deployment descriptors, as you are mentioned, as it is mentioned here, where you can say, well, the database is located in this pod. You can have different services or different versions of DHIS2 running in different pods at the same time, and actually there could be connecting to the same database that you're going to have in another pod running or in another service. And you can optimize for each of them, which is the CPU level that they need. For instance, here you have something, an app that is running with 600 millicores of CPU, not even one, and they are going to charge you in the cloud for the use of 600 millicores, not one core or one complete core. You're going to have 300 seconds for RAM as well. Then you have some smaller levels in this case. that is going to be measured in millicores. And actually, if you don't have enough for using all the CPUs that you need, or I mean, for instance, if you have 3 CPUs available, because that is what the node has, and you request 1.5 CPUs, and they are going to run correctly. And the third one is going to be throttle. That is the orange color that you have there. But your app is going to still run even if you have these issues. And that's something really important at infrastructure level. And for memory, you're going to have the same. You have bytes, kilobytes, megabytes, and gigabytes that you can control as well. That is different than the gigabytes, just in case, because they are measured for the disk. And for the CPU, as I mentioned, you have the millicore when you have different shares, and you can optimize them as well. Oops. It's stuck. Well, the important thing here and what you can do with this is, as I told you, you can have high availability at different levels. You can have multiple pods running, and actually you can update versions pretty fast and simple. I would say, for instance, we started working with 2.38 version on October. Then we moved in January to 2.39, and we are actually working now at version 40. You know that you changed the nomenclature. And actually it was pretty simple. You launch version, the DHIS2 team launched version 40 like a month ago, as Austin said, and we were working with it like 48 hours later in our development environment. We tried everything that we wanted. And actually a week after, we were working in production already, because we knew that it wouldn't affect the functionalities for the user, not for the administrator at our level, but still, it was pretty cool. And the user was pretty happy with this change, at least for the icons. With the icons, that was pretty good for them. And actually, we didn't take down the service as you do with other services or with Docker Compose sometimes. And then that was pretty cool as well. And what we are doing now, because I'm just telling you what we do with Kubernetes, and we are gonna share this with everyone because the community helped us a lot. Then we are gonna give it back to the community. We are gonna give this infrastructure deployed in Kubernetes using Terraform. The idea of this is that even though we're deploying it in Google Cloud, at this point, we are gonna release the scripts using Terraform for deploying this easily in AWS, Azure, DigitalOcean, Oracle, or whatever you need. The important thing here is that this infrastructure could be deployed with Terraform. And well, we did some testing a few days ago, and in 2.5 minutes, you can have an entire infrastructure running. And in a few minutes more, you can deploy the workload, and you're gonna have cloud native infrastructure for DHIS2 and deployed in a few minutes. And this could manage an entire country registry, not only at aggregate level, but also at tracking level. Just for instance, we started working with this because during the pandemic, we were challenged. We registered around 33 million registered for PCR at nominal level, and we need the same level of infrastructure for handling something like this. Well, just if you want to collaborate with us or know a bit more, you can contact me, or you can contact the team actually at DHIS2 at MinSal, that is from the Ministry of Health of Chile. Well, and that's my presentation. If you have any question, you can ask them.
Thank you, Felipe. I don't think you can hear the applause, but there was a lot of applause in the room for you as well. Thank you very much for sharing. Does anyone have any quick questions for Felipe? And then we'll turn it over to Nacho to give a quick presentation as well. Very impressive. Yeah, Mozafat.
just the cloud case in general, does it make sense for African countries when there are no AWS or cloud regions, just maybe in South Africa? Would it make sense? Will it get, high availability and performance if you are in East Africa or West Africa, if you don't, the closest center is in Europe?
Yeah, in that case, you're going to have a delay. I don't know what the legislation is within African countries, but anyway, you can do the deployment. You're going to have a bit of delay, but it's not going to be much because you can deploy still in Europe. And actually, it's pretty fast. The problem is that you're going to be handling all the South African, for instance, information in Europe. Although they have the GDPR, you need to see whether that complies with your own legislation. Actually, it's a bit difficult, but I would recommend you to try it. And if it works for you, well, that's it. But at least I'm going to tell you that it's going to give you high availability with a bit of delay, but people is not going to notice that. Actually, I didn't say it, but we have a data center here in Santiago from Google, and that's why we started working with it. And it's always good to have a data center close to your country, but still, if you use from another country, for instance, we can use the US-based one, and it actually works pretty well. Then it would be something similar. It depends on connectivity as well.
Yeah, I think just a general comment on that. That I don't know, Bob, if you have some thoughts on that as well. But yeah, generally, I would say it's important to test, right? To test the latency to different geographic data center locations. There aren't. It's true that there aren't any AWS or Google data centers outside of South Africa on the African continent that I know of, but I think there is some plans to open one in Nairobi potentially, or a couple other places. So, yeah. Oh yeah. Sorry, I didn't understand. Edge. Oh, sorry. Yes, I was NH. I was confused. An edge server. Yes. Yeah, there is an edge server, but I think it's important whatever the country requirements are to test and to see what works. There's also, I think, some advantages to exploring multi data center deployments potentially. If you have one that's local and then another one in the cloud, to be able to have some redundancy there. That could be something to explore as well, but it really depends. Bob, did you have something to add on that?
Yeah, thanks, Felipe. That was really interesting. What struck me when you were talking about the allocation and costing per resources used is that a lot of these new developments, just like capitalism reshaping itself, selling a product. But it might make developers start to think a bit differently, that now a particular program indicator, for example, you can put $1.00 cost on it. That's going to cost you $10 a month just for that. Program indicator that uses 100% of CPU for 5 minutes, or running analytics every night, that costs you $20. It's an interesting new way of looking at optimization.
For sure. Yeah. I think we have 5 minutes left, so I'd like to turn it over to Nacho. I know he had another presentation that we kind of split between the non-technical stuff, and I wanted to give him a chance to talk about the technical stuff. So I'll go ahead and give you, actually, it's probably easiest if you use that one. Thank you very much, Felipe. Really great presentation, and it's really exciting to see all the work that you're doing and sharing with the community around kind of repeatable, high availability deployments of DHIS2. I'm so excited to work with you more.
Okay.
Thanks.
Can you hear me? Is it okay? Can I pass by? Yeah, both. Both. one with this. Okay. Okay. Yeah, I pass. Okay. Is it working? No. Can you use this one or is it okay? Yeah, I tried. Yeah, it's working. Okay, so I will be fast because we don't have too much time.
Sorry about
How many minutes?
that. 5.
5 minutes.
Yeah,
Okay.
sorry.
And it's not only me. I'm Nacho from ICT. I'm CEO at ICT, and I have in remotely my colleague Adrian, that is a project manager also in ICT. We're here to present you D2 Docker. D2 Docker, who is actually part of a big suite of generic applications, and maybe some of you know about them. We're trying to create community with this. What we try to do is basically generalize the problem of a certain client that we have in order to make it possible to be used for all the community. Everything that we are building is open source, and so please do not hesitate in going into our website because we have all the explanations on this. I go fast. And so basically this is what happened to us. As sysadmins that we are also that are managing the DHIS2s, we were bothered all the time by, please can you dump a database? Please can you test this? As developers also, we were needing backends for testing the front ends that we were building on top of the DHIS2s. And so that's why we built a CLI to run them all. So D2 Docker, trying to help. D2 Docker is nothing but a Python wrapper on top of the Docker Compose. So it's a multi-platform system. You can run it on Mac, you can run it on Linux, or Windows. And it's nothing but configuring your Docker Compose in a way that you can run locally, or you can expose it then later to the world, a series of Dockers, basically. It is helpful for implementers. Like imagine, for example, you need to create some different variants of some metadata, and so why not just tightly exposing that metadata in a DHIS2 instance that a certain country can run locally and can operate on that and can submit modifications that you can work on. You can also train even on a certain piece of metadata, go into the country, and with a bare bundled server with your own computer, you say, okay, please connect to this machine. And every time that you will run that, it will be reset to the original. If you don't commit, if it will be reset to the original status before you launch it, the instance. It works for sysadmins. Like imagine that you need to create copies of production. How many times did someone ask you for that? Environments to debug. No longer debugging on production directly. You download locally, you run locally the instance, and then you debug there. Afterwards, you go to production. Getting a DB copy, automating deployments that much easier by having Dockers. And even for developers, as I was saying, like you want to run CI/CD tests that you're running on your applications, so you can run it automatically by using GitHub Actions or whatever. I'm not going to explain you the use case of with it because otherwise I think Adrian won't talk. But just to tell you that we are using it in real time in the largest DHIS2 installation in WHO that is having more than 8 departments now, inputting the data inside. It's a common platform, and they are using Dockers for all the environments but production. And they are using this tool for doing that. So you have 2 ways of running it. You can run it like in your machine, standalone approach, and then you can have also your own Docker registry. I have seen in a previous slide, so Docker Hub that is perfectly fine, but you know that you need to pay for Docker Hub. So what we do is to use Harbor, which is another Docker registry. Basically, on all of the deployments, we just configure it. It's open source. You can download, you can use it, and you have your own Docker registry. Installing it is as simple as this. This is literally a screenshot from how do you install it in Linux. In Windows, we have a wonderful guide in a wiki, and in Mac, the wonderful guide is even longer. So it's just executing a command, and then basically this is the structure of your image. You have two things. That's the only thing you need to retain is two things. One is the core, and the other one is the data. So you can basically change the core and run the same data and applications on top of a different core to see how your data behaves in a different DHIS2 version, for example. And that's all managed from the command line with this. This is a help message of the command, and you will see that you can easily copy in a couple of seconds an image. You can list the number of images that you have. You can commit, you can push to your Docker registry, and you can start an image, obviously. And then the very last command that you have there, that is D2 Docker API, is to run an application that is exposing an API. And that basically is what Adrian is going to tell you. I'm not going to show you the demo because we don't have time. Please, Adrian, if you're around.
Yeah, can you hear me?
Yes.
Yeah.
Okay, super quickly. So basically, I'm going to talk about D2 Docker application that is basically a wrapper on top of D2 Docker. That is what Ignacio has just explained. The idea is that we have built a graphical interface to do all this kind of action from a web browser. Next. Yeah. So.
Sorry. Yeah.
So basically, the idea is that we have this Harbor. Harbor is something like a Docker repository, same that you have with the source code in GitHub, but this is called Harbor. And then you have D2 Docker application that is on the middle. The idea is that you can basically fetch a Docker container. It's actually Docker Compose, what we have in here, but fetch a Docker container and start an application. By application, I mean DHIS, running a Postgres database, and so on. Next. So in this Harbor, you can basically have different Docker instances. I am giving you 3 examples. You can have training instances that you want to start in a laptop, in a server, in a computer anyway, or a real case that is the one that I'm going to talk next about, that is emergency. You can have a skeleton or a production server without data. And with this D2 Docker application, that is a web interface, you can basically say, okay, I want to start an emergency or a training container. It will download the server for you and start with a couple of clicks. You can also do some other actions as the one that we have there. Next. So yeah, okay.
Adrian, we are a little bit over time. I'm really sorry that I made you rush, but we have the next group coming in here. So if you could just wrap up quickly, that'd be great. Sorry about that.
Yeah, no worries. To screenshot, this is the one to create a container with only 4 fields. Basically, in the first field, you can select the container, and then you can say, okay, I want to start it. This is basically the dashboard where you're going to be controlling the different servers that you have in there, and you can execute this action. Next. And this is the use case. It's basically the emergency free hospital that we have used in Ukraine, in Turkey, in Malawi. And the idea is that basically you execute a single line in the command line, and this will start the D2 Docker application in the web browser. Basically, you download the emergency free hospital skeleton. You do some customization by pulling the data, the metadata, and the server actually, the laptop is ready to go to the field. This pull metadata is the important thing. Next, Nacho. Because basically these 2 boxes happen in a web browser, so that yes, you execute a single line, a single instruction in the command line, everything from the browser, from this interface, and then with the pool of metadata, you are going to be doing the customization. Customization does obviously have to do with the response. In this case, if you go to Ukraine, for example, in our case, we need to have questions regarding the surgeries that are taken care of, or if we go to Malawi, as we went, it's basically more about cholera, and the questions are slightly different. And this somehow is all. I don't know if you get the idea, but this was the concept. Thank you.
Thank you very much, Adrian and Nacho. We get some applause here. This group, this will also be presented with the focus on the use case in the next session, I believe, right? So thank you very much. Apologies for the rush.
No problem.
Yeah. And just in general, I think we're going to need more than an hour next year, because I think this is a big topic that a lot of people are interested in. And yeah, you might see some more of this in the What's Next in DHIS2 session on Thursday as well. So thank you everyone for joining, and we'll move on to the public portal session, which is the next one, public dashboards.